Hello, um, today I'm going to be building a dummy load. They're quite expensive now for one of a higher rating. It'll be good for CB, which is 27 megs. Right, I'm just grounding out the SO239 to the case. Well, yeah, I mean it's good. Presents a good 50 ohm load to the transmitter. The difference with this one is I'm going to put sensing on it, so I can take readings when I'm keying off. So yeah, this is what I've done so far. I put some banana jacks in, so that's where your voltmeter goes. You have to have I think it's a 0.1 microfarad cap across those two, so it charges up. Super fast recovery. Diode. So that'll be going to the positive banana post. So this is what I've started with. 1K, 3 watt metal oxide resistors. Colours brown, black, red. So they look like this. Oh, there you go. These are Mitsubishi's, but you could use any brand really. Alright, so back up a bit. There we go. Anyway, I've got 20 of them. If you wire them in parallel, you'll get 50 ohms once tested with a meter. Should read like, here's one I made earlier. So if we go on the resistance range, I don't know if you can see that, can't you? So if I put that there, should get where are we? There we go, look, 50.5. That's what you want. So it's 20 of them in parallel, using copper clad discs like this. You drill holes, 20 holes. Feed your resistors through, solder them both ends. Get a terminal from one and the other and wire it up to the SO239 on the back of here. Yeah, and this diode, which is a BAV21. That goes like this onto this terminal here, what I've kept on there. Solder that onto there like so. And then that'll go up to the positive jack of this banana plug there. Look. Yeah. I mean, I built one before. This doesn't have sensing on it. And I've soaked it in motor oil. And it's been alright, I've had this for several years. Still 50 ohms. It ain't degraded any. So what we're going to do now is solder a wire from there to here, which I've already done. And then we're going to get the whole thing and solder it like that, so it's in the centre of the lid almost, like so. and then you've got to get the ground wire onto the lid, as well as that outer jacket of the SO239, so it's all grounded. But this goes on the centre pin, like so. Yeah, so that's where we're at the moment. Alright, just put a bit of heat shrink over it, clear. See, so we don't touch any of that. So I'll heat that up and shrink it on there just now. I'm just soldering a little terminal onto there, onto that diode, so then it can be bolted onto there like so. So I'll get that on there. Like so. And I'll solder that on. Brilliant. There we go. Soldered on there like so, look, if that's clear. And then we've got to figure out how to get this terminal, which is the ground, sorry, the positive, which goes into the centre of the SO239. We've got to try and route that so it's all sort of perpendicular. There we go. So it's like that. So whilst I figure that out, I'll just pause the video. So I managed to get that on there. At the bottom of the copper clad onto the centre of the SO239, and we've got the signal diode going to the positive of the banana jack. Now we've just got to get the ground side sorted from here, from this end, up onto a ground log there, and then that would be pretty much complete. I managed to make a terminal of quite thick gauge copper with a ring terminal on the end, which is going to go from this banana plug, which is there, and then up onto the back end of the resistor bank. So it's like that. And that'll serve as its ground. So I'll just solder that on. And then I'll get back to you. So there you go. It's all wired up. That is a 50 ohm dummy load, which out of the mineral oil would take 60 watts. And if you submerged it in mineral oil, it'll give you 130 watts constant. Now the signal part of it, you connect this to a digital voltmeter like this one, and you factor in the voltage drop across the diode. What you end up with is your output in watts. which is good for it's good for testing your transceiver out and that kind of thing. But, they're quite expensive really, but quite simple to make. It only cost me like all in. I mean, these are scavenged parts. These are like the banana plugs. That's off an old power supply. That's off an old. I think it's a jumbo, International jumbo. That's off. These old bits of copper clad I had knocking around. The only thing I really bought was the diodes and the resistors. Yeah. Let's see if it's 50 ohm there now. It should be. Right. Oh shit. Yeah, look at that. That's what you want. Obviously, if you transmit with a poor antenna or no antenna at all, it's going to wreck your transceiver. That's why it's good to have one of these. Yeah, so it's simple. Next stage, we'll be testing it. Right, if you take note of the SWR meter just here, if I key up, there's a dummy load on top connected to it. I'll show you. Just there. Now I'll key up. See the SWR? Really low, 1-to-1. And I've got full 20 watts output. See? So that works. That's on CB as well. Right, so any videos on. So there, this is the radio I'm using. So Yaesu FTDX 1200 HF 6 meters. Yeah, 27 megs though. Absolutely brilliant. See, I could increase the power, to say like 60 watts, but I'm running on my solar at present. I can't draw too much in one go. It's quite a bit of power consumption. But look at that. 1-to-1. I hope that was helpful to you in some way. Sorry about the quality in the video and that. Just to finish, if you want to know the ins and outs of the dummy load, how to build it, the schematics, where to get the parts, drop me a message in the comments below and I'll send you the schematics from the original author, which is K4 EAA from America. I think his name is Ken Kemski. He's the author of the information and the how-to. So I'll give you a link to his website as well. It's a useful tool to have in your Radio Shack, to be fair. Always handy. Anyway, take care for now. See you in the next one.